Hi, grade 11 students. We're going to continue by logarithmic function. We know that exponential function is a number raised to a variable power, like here. And if b is bigger than 1, it's growth, increasing, strictly increasing. If b between 0 and 1, it is decay, which is decreasing, strictly decreasing. And we know from grade 10, if a function is strictly increasing, or strictly decreasing like this one, it admits an inverse function, and this inverse function is symmetric with respect to line y equal to x by taking perpendicular and same distances. We did it in grade 10, so you're going to get the inverse function. But so since exponential is strictly increasing or decreasing, decay or growth, so it admits an inverse function. And the inverse is what? You take the power like here, you write it as x, you have base a. The inverse of exponential is equal log base a of the answer y. So we take the power, we write x equal the base here a, we write it as log base a. It's named by log. Inverse of exponential is log of the answer, which is y. And we all know that since here y is always positive and x, because exponential is always positive and x can be anything, so the answer of logarithm can be positive and negative, but inside must be always positive. And if the base a is e, so we write x equal log base e is nothing else than ln. Log base e is named by ln, and as we know that the Neperian logarithm was discovered by John Napier. So x will be ln of the answer y, and if you have 10 power x, 10 is also, it has its own characteristic. It is denoted by log without base. If you have a log without base, it means the base should be 100% 10. So here we say x equal log base 10, so we don't put 10 if you want, of the answer, which is y. So this is the inverse of a logarithm. And you can go backward. I mean backward. If you have here logarithm, you start from inside. Y equal a power x. Here y equal e power x. Here y equal 10 power x. So let us start. Let us take problems. Suppose I want to solve here. I take the 4 to the other side. Then I divide it by 2, which is 5. So I write x minus 2. Inverse of exponential is ln of the answer 5. You can take 2 to the other side. You have this expression. You can use your calculator to find the final answer. Here I take the 20 to the other side. So minus 25 over minus 5. You have this one. So I want to write in logarithm to find x. So I write 2x minus 1 equal. Here the base is 10. So I write log base 2 of 5. And you take the minus 1 to the other side. It will be log base 2 of 5 over 2. In calculator, log base 2 of 5 is nothing else than ln 5 over ln 2. Okay, so you can use your calculator to find that answer. Here you take 12 to the other side. It will be 3 minus 12, which is minus 9. You divide it by 5. You all know exponential equal negative is something impossible. Since exponential can never be negative, so we write it is impossible. Another example here. You take the 7 to the other side, it's 15. You divide it by 3 is 5. We start minus 2x plus 1 equal log base 10. No need to put the base 10 as we said. Of the answer, which is 5. You take minus 1 to the other side, then you divide it by minus 2. This log base 10, it exists in the calculator. So you can write it directly in calculator log 5. And you get 0.15. Here you take the 3 to the other side, it will be 10 over 2 is 5. Now I'm solving for ln. For ln, I start from inside, x minus 2 equal, inverse of ln is exponential of the answer, which is 5. So x will be 2 plus e5. You can use your calculator to get that answer. Here I take the minus 12 to the other side, it will be 12. 12 over minus 3 is minus 4. Logarithm can have an answer of negative, contrary to the exponential. I start by minus 2x plus 1 equal 2 power answer, which is minus 4. So I write it here, the minus 4. So x will be minus 1 plus 2 power minus 4 over minus 2. It will be 15 over 32. Now we're going to continue by the same. So now I'm checking the time if how many minutes are left. So I take minus 4 to the other side, it will be plus 4. Then I divide by 2, it's 2. Now, if you don't have a base, it means the base is 10. No need to write it as we said. This is the same logarithm. I start from each side. X squared minus 1 equal 10 power what? 2. So it's 100 plus 1 is 101. If you remove the square, you put plus or minus square root. Now, what does this mean? What is e power 2x? E power 2x can be written as ex power 2, power for power. So what we have here is an equation of second degree, but in exponential. It's like 2x squared plus 5x minus 7, where x is nothing else than exponential, ex. So I do delta, a is 2, b is 5, c is minus 7. You're going to get 81. You can check it. Bigger than 0, I have two distinct roots. The first root is minus b plus radical delta over 2a. The second minus b minus radical delta over 2a. Or you can use your calculator directly if calculator is allowed. You're going to get 1 and minus 3.5. Ex equal to 1, so x equal inverse of e is ln of the answer 1, which is 0. Ln 1 is always 0. And ex equal minus 3.5 is impossible because exponential can never be negative. Here I have 2 ln square of 3x minus 5 plus 5 ln 3x minus 5 minus 3 is 0. Ln square of 3x minus 5 is nothing else because the square is on n, not inside. Inside, it's something else. However, because the power here is on n, it means on the whole expression. So this is also an equation of second degree, but in ln 3x minus 5. So I do delta, a is 2, b is 5, c is minus 3. If I do delta, it's 49 bigger than 0. I have two roots. If you do minus b plus or minus radical delta over 2a, one of the roots is minus 3. So 3x minus 5 inverse of ln is equal e power minus 3. You solve for x. And the second one, minus 3 over 2. You do 3x minus 5 equal e power minus 3 over 2. So x will be 1.74. Now I want you to solve these for tomorrow, which is solving for x. Now we're going to continue by another part about domain. This is very simple. Why it's simple? Because if you have logarithm, the domain inside logarithm always must be bigger than 0. So here the question, find the domain. So since you have x minus 2, you say x minus 2 bigger than 0, x must be bigger than 2. Here you have minus 3x plus 9 must be bigger than 0. So minus 3x bigger than minus 9. Because coefficient of x is negative, so x must be less than 3. Anything above or equal to 3 is rejected. Here x squared plus 5. You all know that x squared plus 5 is always positive. So it's impossible to be 0 nor negative. So domain is everything. Here if you continue, I have x squared. X squared is always bigger than 0. But I must exclude what? The 0. Because log 0 is impossible. So x not equal only 0. Every value of x, even it's positive or negative, when you square it, it's positive, except the 0. So here I have up positive. To be accepted, down must also be positive. So I say 3x minus 6 bigger than 0, x bigger than 2. I want you for tomorrow also to do the second part of homework. Find the domain of these exponential function and see you tomorrow in school.